the beginning, God created the heavens and the earth. The earth was formless and empty. Darkness covered the deep waters, and the Spirit of God was hovered above the surface of the waters. God said, "Let there be light," and there was light. God saw that the light was good. Then he separated the light from the darkness. God called the light day, and the darkness night. Evening passed, and morning came, marking the first day. Then God said, "Let there be a space between the waters, to separate the waters of the heavens from the waters of the earth." God called this the sky. Evening passed, and morning came, marking the second day. Then God said, "Let the waters beneath the sky flow together into one place, so dry ground may appear." God called the dry ground land, and the waters seas. God saw that it was good. Then God said, "Let the land sprout with plants, trees, and trees that produce seeds that grow fruit." And God saw that it was good. Evening passed and morning came, marking the third day. Then God said, "Let lights appear in the sky to separate the day from the night. Let them be signs to mark the seasons, days, and years. Let these lights in the sky shine down on the earth." God made two great lights, the sun and the moon. Then he painted the night sky with stars and saw that it was good. Evening passed and morning came, marking the fourth day. Then God said, "Let the waters swarm with fish and other life. Let the skies be filled with birds of every kind." And God saw that it was good. Evening passed and morning came, marking the fifth day. Then God said, "Let the earth produce every sort of animal, each producing offspring of the same kind." God saw that it was good. On the same day, God said, "Let us make human beings in our image, to be like us. They will reign over the fish in the sea, the birds in the sky, and all the animals." So God created human beings in his own image, a male and a female. God blessed them and said, "Be fruitful and multiply. I have given you everything that has life." Then God looked over all he had made, and he saw that it was very good. Evening passed, and morning came, marking the sixth day. On the seventh day, God had finished his creation, so he rested from all his work. God blessed the seventh day and declared it holy.
It's KarenEnglishTeacher.com. Yeah! 3, 2, 1, sing. La 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 la. Hello, students. Today I'm going to teach you another sentence in English. First, let's read. Can I go to the washroom, please? Now with actions. Can I go to the washroom, please? What are you doing here? Can I go to the washroom, please? No. Oh no, oh no, oh no. I'm just kidding. You can go. Thank you, thank you, thank you. La 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 la.
Emotes using the new note blocks.
What is the largest star in the universe? And why is it that large? And what are stars anyway? Things that would like to be stars. We begin our journey with Earth, not to learn anything, just to get a vague sense of scale. The smallest things that have some star-like properties are large gas giants or sub-brown dwarfs, like Jupiter, the most massive planet in the solar system, 11 times larger and 317 times more massive than Earth, and more or less made of the same stuff as our Sun, just much less of it. The transition towards stars begins with brown dwarfs, failed stars that are a huge disappointment to their mums. They have between 13 and 90 times the mass of Jupiter. So even if we took 90 Jupiters and threw them at each other, although fun to watch, it wouldn't be enough to create a star. Interestingly, adding lots of mass to a brown dwarf doesn't make it much bigger, just its insides denser. This increases the pressure in the core enough to make certain nuclear fusion reactions happen slowly and the object glow a little. So brown dwarfs are a sort of glowy gas giant that don't fit into any category very well. But we want to talk about stars, not failed wannabe stars, so let's move on. Main sequence stars. Once large gas balls pass a certain mass threshold, their cores become hot and dense enough to ignite. Hydrogen is fused to helium in their cores, releasing tremendous amounts of energy. Stars that do that are called main sequence stars. The more massive a main sequence star is, the hotter and brighter it burns, and the shorter its life is. Once the hydrogen burning phase is over, stars grow, up to hundreds of thousands of times their original size. But these giant phases only last for a fraction of their lifespan.